In section 5.3, we're dealing with mechanical energy and the conservation of mechanical energy. Let's look at a quick example. Here we're going to have a projectile that's fired from the top of a building. Find the final speed of the object just before it hits the ground. After it hits the ground, the speed's going to go to zero very rapidly. We want the actual free fall part of the motion right before the object hits the ground. How fast is it going? This is a problem that we could have answered in Chapter 2, but we're going to see that using some Chapter 5 skills, probably it's a good bit easier to get to the result. Conservation of energy, you have to ask the right questions, and this one is just right, asking about the final speed. And the picture, I apologize, really need to update this one so it looks a little bit better. The initial speed of the object is 20 meters per second. It's fired at an angle of 32 degrees above the horizontal. The height of the building is 58 meters. The final velocity vector is indicated. We also have the coordinate system almost kind of hiding there. But I'm taking to the right to be the positive direction and up to be the positive direction. Well, let's see how to solve this problem. Here's the picture again, just for easy reference. And, well, let's see, to work this thing out, let's note that the energy is mechanical. There's the kinetic energy as the object is moving, and it also has a vertical aspect, so the height of it, that's going to bring in the gravitational potential energy. Both of those are mechanical. If we ignore air resistance, we're in pretty good shape. Now, to work this, we're going to say the mechanical energy at the start of the experiment is going to equal the mechanical energy at the end of the experiment. The initial and the final values are equal. Let's replace the mechanical energy by its constituents, the kinetic energy and the gravitational potential energy. The sum of the initial values will equal the sum of the final values. Kinetic energy is 1/2 mv squared, gravitational potential energy mgy, and now just substituting in with the initial and final values for the speed and positions. Now let's plug in, well, even better than that. Notice that each of the terms in the free fall for one object in motion, each of the terms includes the mass, and we can divide both sides of the equation by the mass and it cancels out. So a simple rewrite of the equation makes life a little bit easier. Now let's plug in the values that we know. The V initial is 20 using SI units, G is 9.8, the Y initial is 58, the Y final is 0, and we're looking for that final speed. This equation can be solved to yield that the final speed is about 39.20 meters per second. I think the next slide is going to comment, just to finish this off very quickly, it's going to comment that this result did not depend on the mass. Well, we already kind of commented on that. But notice it also doesn't depend on that initial angle. 32 degrees doesn't show up in the problem anywhere. As long as the initial speed was 20 meters per second and the height was 58 meters, the result would be the same. So had the object been shot straight up at 20 meters per second, by the time it got down to the ground, it'd be 39.2 meters per second. Or had it been shot horizontally out, the result would be the same. Anyway, shifting over to the final slide so we can see that in writing. Couple notes. This result did not depend on the initial angle. That's pretty cool. And also the mass was not needed. Cancels out in the problem. So even had the problem specified the mass of the object, that would just be superfluous information for a free fall type problem. And that knocks that one out very quickly.